All right, so let's do a beastly problem. Let's do a big one. And I think I'm just going to set it up, not actually solve it. Oops. Okay. So we want to find this area. We got we got a line, we got a parabola, we got a square root function. We can do this in terms of x's and in terms of y's. I think doing it in terms of y's is a silly proposition, so let's do it in terms of x's. So when we do this, we'd actually have to break this up into two pieces. Have some area 1 and some area 2. But what we need is some points of intersection. And it's not the y values we care about, it's the x values we care about. We have to figure out what are those values of x so we can find our bounds of integration. So first, let's find this point, or just the x value. So we need to figure out where is it that 4 times the square root of x equals negative 4x plus 6. How's your algebra, y'all? How's your algebra? Because this is going to be a beast. Just doing this alone, I imagine, would stump a lot of students. But our algebra must be on point. So this is dangerous typically, but we're going to square both sides. So we're going to get 16 times 2x is equal to, when we square this other side, what's that? 16x squared. Negative 4 times 6 is negative 24. Multiply that by 2. That's negative 48x. And then we square our last term, and that's 36. So let's take this 32x, subtract it over to the other side, and we get, zoom out a little bit, 32, 48, 80. Okay, and now I think you can take a 4 out. 4x squared minus 20x plus 9. Let's divide out our 4. You have a pencil, don't you? There we go. Now we have to solve this. Now I use this weird little trick. I'm assuming it's factorable. You can use the quadratic formula if you want, but I don't know. This little trick, it's not equal in the meantime. Students call it the weird uncle trick. And now we factor this up. So we take that 4 off the front, multiply it by our c. This is the diamond method, just in a process. So two numbers multiply together that equal positive 36 that sum to be negative 20. I think that's going to be negative 18 and negative 2. Now that we have it, we need to divide out that 4, reduce. And this is going to end up becoming 2. Oops, sorry, I'm jumping steps if you haven't seen this before. But you factor however the heck it is you factor. I'm just reducing the fractions, and then you bring the denominator over to the leading coefficient. But again, you know how to factor. I don't need to help you with that. And then we go through and we solve. So x is either equal to 9/2 or x is equal to 1/2. But by inspection, just looking at this, it's not going to be 9/2. It's going to be 1/2. Just by the inspection, because it will hit twice. We can see that it hits twice. Okay. Ooh, my goodness. My goodness. This answer actually wouldn't work. All right. So x is equal to 1/2. Whenever you square both sides, you get things called extraneous answers. It doesn't actually hit twice. I was silly. I was stupid on that one. It doesn't hit twice. One of them's an extraneous answer. It doesn't actually work if you were to plug it back in. You'd end up with a negative on the right-hand side and a positive on the left-hand side. So it's only going to be 1/2. How's your algebra? All right. So we found that bound. Let me get rid of all this. Oh my goodness. So much. So much stuff. All right. And now we're going to move into solving on our next one. We did the tough one first. All right. So now we want to find that guy. So that's going to be our 2x squared, right? What's in red? And we set that equal to negative 4x plus 6. Let's take it all over to one side. Set it equal to 0. Factor out your 2. Divide out the 2. And then we're going to end up with what? X minus 1, x plus 3, set equal to 0. Therefore, x equals 1 or x equals negative 3. But we're only looking in the first quadrant here. So everything's positive. That can't be the answer. So there we go. X is equal to 1. All right. So we've handled our first 2 points of intersection. Now we need to handle our last point of intersection. And then we're going to be able to find all of our areas. So let's now get rid of this. Get that nonsense out of there. Now we want to take our 4 root 2x and set it equal to our 2x squared. Okay, so let's divide by 2. Let's start off. Now let's square both sides. Again, danger happens when you square both sides, but I think we're going to be okay. Let's take it all and set it equal to 0. We get x to the 4th minus 8x. Let's factor out. Let's factor out the x, and that leaves us with x cubed minus 8. Therefore, x equals 0, or x cubed minus 8 equals 0. Oh, we can see, yes, there's a point of intersection down there at x equals 0. We don't need that. And then we say x cubed is equal to 8. Hit it with a cube root, and you find out x is equal to 2. Ooh, that was just to find the gosh darn bounds. We are 7 minutes into this, and we haven't even set up the integral yet, but we're about to set it up. And then I'm going to stop because I don't really care about the answer. I care more about how do we set it up. Because we can all do algebra. So, our area 1 is going to be the integral from 1/2 to 1. Our top function is that 4 root 2x. Our bottom function is that line, negative 4x plus 6 dx. And then we would have to add it to our area 2 function, which is going from 1 to 2. Our top function is still that 4 root 2x, but now our bottom function is the 2x squared. So our total area would be the integral from 1/2 to 1 of 4 root 2x minus negative 4x plus 6 dx plus the integral from 1 to 2 of 4 root 2x minus 2x squared dx. And then you go through and you solve that bad boy. Lots of fractions, lots of fun stuff. Oh my goodness, is that going to take forever? But we set it up. Who knows? Maybe you have a problem on your exam where I just say, hey, set the damn thing up. We don't actually go through and solve for it. Well, that would be the setup. This is a lot. It's a lot. This is actually one of the more straightforward sections, but as we learn, I mean, everything new is kind of tough. But you'll look back at this later and be like, I kind of miss this stuff. Maybe, I don't know. I don't know who you are. So, all right, that's the end of our 6.2 section. We're going to move into volumes of revolution next, and we'll have fun with that. All right, see you.